have always been fighting. And now, it's time to stop. With the creation of the thermoelectricity, we can obtain power. We will stop all the fuss and create a world where we have temperature peaks.
Hot rod, huh? This car uses electrical energy to move. And the energy that's stored to get electricity is stored in the battery pack right inside. This uses electrical energy. Well, let's just go back home and see how electrical energy works, right? Come on, let's go back home. It's freezing out here. Hello, I'm Ahmed Salamoglu from Harmony Science Academy, and today we'll be talking about thermoelectricity.
In 1821, about 200 years ago, thermoelectricity was discovered in Western Europe by Thomas Johann Seebeck. He found that a circuit made from two different metals with sides at different temperatures would deflect a compass magnet. Seebeck theorized the deflection was due to the magnetism induced by the temperature difference.
As you know, there's a pool of electrons in the middle. They just keep on switching their central atom just in nanoseconds. Batteries are places where a lot of negative and positive electrons are stuck in a place, and they just want to run out of the battery. The negative side is always attracted to the positive side, and the atoms on the negative side have one more electron than usual, so the electrons on the negative side get attracted by the atoms on the positive side, which lacks one electron from the atom that it can take in. And basically, when you connect a light bulb or a motor in the middle of the connection by the help of a wire, you give a way for the electrons to move and be balanced again back on the positive side. Well, you might ask, how does thermoelectricity work? Thermoelectric generators work by exploding a temperature gradient between the two sides of the generator. If you take a piece of metal and heat it on one end while cooling it on the other, the electrons on the hot side of the metal will have more energy than the electrons on the cool side, thus moving the most of the electrons on the cool end, causing a negative charge on the cool end. This is called the thermoelectric effect. The voltage produced with one metal is very small, so we'll need more to obtain voltage. This is where the positively charged metal comes in handy, which is the stainless steel we have right here. Because the positively charged material also moves away from the hot side, it can give us a chance to link the metals together to make more electricity. This positively charged material is called a semiconductor. It's basically the opposite of a conductor. And in terms of thermoelectric factors, there's about hundreds of these in a compact thermoelectric generator.
The question is, what would be the ratio and temperature used to get the best results from the thermoelectric generator? These are the results for the thermoelectric generator.
The test was to see the most effective ratio of a thermoelectric generator to find the best productivity. The results are shown. So basically, that question was answered by the more difference, the more.
For my ELA component, I created a newspaper article to explain the behavior of electrons and the future usage of thermoelectricity.
The next step was, can it be converted to real power? And can we use that power? I made this car where I lit up the fire on the bottom and the thermoelectric generator, and I put the thermoelectric generator on top and also ice on top to see if it generates power.